at example for fx equal to 3x squared plus 2x plus 3. Okay, there is a quadratic function. We have learned about this quadratic function in topic 1. Okay, let's say the question is find the relative extrema for fx equal to 3x squared plus 2x minus 3. Okay, the relative extrema is referred to the you need to determine the minimum point or maximum point. You need to decide that that point. The relative extrema point is whether there is a positive or negative. Okay, we can apply the first derivative and second derivative to determine whether the whether uh, that point is a positive or negative of a maximum or minimum point. I will show you how to find the this point. Okay, okay. Please refer to this page, page number 8. Okay, let's say okay, let's say given in the question is fx equal to 3x squared plus 2x minus 2x minus 3. Okay, we want to find the relative extrema or relative extrema minimum is also known as is also equal to the minimum or maximum point. Minimum or maximum point. Alright. So the first step is find the first differentiation, first derivative, f prime x or dy dx. That is the first step. So the dy dx equal to 6x plus 2. And then for this case, at as I said earlier, at that point, whether the minimum of the maximum, at this point, the first derivative dy dx equals 0. The slope of the function equals 0. So in this case, we need to set the value of the slope of the function equal 0. This is the slope equation. This equals 0. The slope of the function must equal 0 at this point, at this critical point, at this minimum or maximum point. So if x with 6x plus 2 equals 0, what is x? Okay, x equal to negative 1 over negative 1 over 3. So when x equal to negative 1 over 3, the slope of the function is 0 in this case. So the relative point, the minimum or maximum point, minimum or maximum relative point occur at this point when x equal to negative 1 over 3. The slope of the function is equal 0. Okay, this is the critical point. Critical point. Now the critical point occur at that when x equal to negative 1 over 3. So we need to find what is y. What is the value of y? When x equal to negative 1 over 3 is x. What is y? What is the value of y? So we just substitute x equal to negative 1 over 3 into the function, into the original function. There is 3x squared, negative 1 over 3 squared plus 2x, 1 over negative 1 over 3 minus 3. So y equal to, we know that there's y equal to negative 10 over 3. That's the value of y. So therefore, the coordinate point, the critical point, the coordinate point of the critical point is 1, -1/3 and -10/3. That is a coordinate point for the critical point. At this critical point, the first derivative is equal 0. Then now we need to decide whether the critical point is a minimum point or maximum point. But now we know that the critical point is occur. There is the critical point. We get the critical point. This critical point, the coordinate point is x equal to -1/3 and y equal to -10/10 -10/3. I think so. -10/3. So now we need to decide whether this critical point is a maximum point or minimum point. So there are two methods here. Okay, the first method, let's say the first method is a first derivative. We just find the first. The method is called as a first derivative method. First derivative method. First derivative method. Okay, so let's say we draw one line here. The critical point is this is the value of x. The critical point is -1/3. That is the value of x. We know that there is a critical point when x equal to -1/3. Now, in order at that point, the first derivative, the slope of the function equal 0. That's the slope of the function when x equal to -1/3 based on the first derivative. Okay, now we need to find the slope of the function before and after this point, before and after x equal to -1/3. Let's say, for example, I choose, you can choose any number. You can choose any number as long as the number is less than -1/3. Let's say I choose -2. I choose -2. So I need to find the slope of the function, the value of the slope when x equal to -2. So the first derivative of -2, okay, this is the slope equation. Okay, this is the slope equation. 6 times uh 6 times 1 6 times negative 6x 6x plus 2. Okay. 6, okay, the first derivative is 6x plus 2. Okay, 6 times -2 plus 2. The answer is -10. So before critical point, the slope of the function is negative. The slope of the function is negative. So we can write here the slope of the function is negative before the critical point. So in other words, if you choose any other point, -3, -4, you will find that all the slope of the function is still negative. Okay, we know that before -1/3, before the critical point, the slope of the function is negative. Okay, now we choose one point, one value of x when after this critical point. Let's say you can choose any value, but for example, I choose 0. I choose x equals 0. So when x equals 0, the slope of the function f prime 0, 6 times 0 plus 2, the answer is 2, is positive. So after this critical point, the slope of the function is positive. Is positive. So when we move from the negative before and after, before the critical point, the slope is negative. After the critical point, the slope is positive. So for this point, we can conclude that the graph is the function is decreasing before the critical point and increasing after the critical point. So we can conclude here the critical point. What is the critical point? The critical point is negative 1 over 3 then and negative 10 over 3 is the relative minimum. Because the slope is changed from negative to positive. After critical point is negative, before critical point is negative, after critical point is positive. So we can conclude here that the graph, the critical point is the is relative minimum point. That's how to identify the relative minimum or relative maximum based on the first derivative method. Okay, that's the first method. The second method, the second method is based on the second derivative test. We can apply second derivative test here to determine whether this point is the relative point is a positive point. Sorry, the the critical point is a minimum or maximum by using the second, let's say the second derivative method. Method number 2, let's say uh, the the second the second second derivative method. Okay, what is the second derivative method? Okay, again, I just write again our function fx equal to 3x squared plus 2x minus 3. And then the first derivative, the slope equation is equal to 6x plus 2. And then the critical point is negative 1 over 3 and 10 over and negative 10 over 3. Okay, now based on the first derivative method, we conclude that this critical point is a minimum relative point. This critical point is the minimum relative point. But now I will use second derivative method. Okay, we are going to have we are going to get the same result here, but based on the based on the with a different method. Well, okay, what is the second derivative method? Second derivative method, we just take the second derivative of the function. Since the first derivative is 6x plus 2, the second derivative is equal to 6. So the second derivative is positive. In this case, the second derivative is positive. So this show that when the value of the second derivative is positive, the graph is concave out. Concave out. We can draw the graph like this. So the also since the graph is concave out, the critical point is this critical point is a minimum relative point. So again, we get the same result here. So based on this example, we can find the minimum relative extrema point. Okay, that minimum relative extrema point is also is a minimum relative point based on the first derivative method and second derivative method. Okay, that's the if you draw the graph, Okay, since there is a quadratic here, when you draw the graph, you can have since the graph A is positive, so the graph must be like this. Okay, that is the minimum relative point. -1/3 and -10 over 10 over 3. Okay, that's the relative maximum relative minimum point based on this graph. Okay, that's about the uh, uh, let's say about the how to find the minimum or maximum point. Okay, I would like to show you another example. Okay, please refer to page 11. Let's say page 11 here. Okay, I have this function x. Let's see which this function. Okay, page 11, y fx equal to x cubed over 3, x to the power of 3 minus 7x squared over 2 plus 6x plus 5. Okay, we want to find determine the absolute extrema point. Absolute extrema point whether okay okay, I think I need to adjust this question in order to show you the graph here. Okay, before that, I don't want, I have one graph. Okay, no. Okay, I will show you this example. Example, which one? Which one? The S squared. Okay, this one. Given fx, page 9. Okay, page 9. Yeah, I have a graph. Please refer to the additional file that I have. You can find the file in UKMfolio. Okay, I will refer to uh, uh, this equation. Given fx equal to 18 uh, 18x minus 2 over 3x cubed, x to the power of 3. Find the interval where the function is increasing and decreasing. Increasing and decreasing. Determine the relative extrema, if any. Okay, again, the relative extrema is referred to the minimum or maximum. Minimum or maximum point. So before that, we need to find the interval where the function is increasing or decreasing. Okay. So now at the first place, I will show you how to answer this question without draw any graph. Without draw any graph. We don't need to draw any graph. No need to sketch a graph. We just apply the first the first derivative and second derivative to answer this question. After that, I will show you the graph. The answer is consistent between the graph and the method that we used to find the answer. Okay, at the first place, I will show you find how to find the interval and how to determine the relative extrema without drawing any graph. Just apply the first derivative and the second derivative. Okay, please refer to this page number 9. Okay, the function is okay. Okay, let's say the function is given in the question is determined page number 9. Okay, the question is, please refer to page 9. Given fx equal to 18x minus 2 over 3x to the power of 3. Okay, we need to find the interval where the function is increasing or decreasing. Okay, that is the where is the question? Okay, that is the question. Okay, I just screenshot this question. How to answer this question? Okay, let's see. Okay, I want. Okay, this the question. Find the interval where the function is increasing and decreasing. We need to and then determine the relative extrema. So how to answer this question? Okay. First of all, we need to find the first derivative. That's the tip. This based on if you see this type of question, the first step you need to find the first. You need to find the first derivative. The first derivative of this function. So fx equal to uh 18x 18x minus 2 over 3x to the power of 3. The first derivative, okay, is equal to 18 minus 2x squared. So in other words, you need to know how to find the first derivative. Okay, there is uh, the slope equation. Again, there is the slope equation. In other words, you need to find the slope equation first before you can answer this question. Okay, from this slope, we can determine the critical point. At critical point, the slope this value, the slope is equal to 0. The slope is equal to 0. Since the slope equation is quadratic, you please use the quadratic formula, or you can use your scientific calculator. You can find the answer. I just skip the step. The answer is -3 and +3. 3 and -3. In other words, there is two critical points here. The critical point is at x equal to 3 and x equal to -3. So the coordinate point, we need to find the coordinate point f3 based on this value is 18 times 3 minus 2 over 3 times 3 to the power of 3. So the answer is 36. This is the value of y. And then when x equal to -3, the value of y is 18 minus -3, 18 times -3 minus 2 over 3 to the power of -3 times -3 to the power of 3. The answer is -36. Okay, there is two coordinate point here. So the critical point, there are two critical point. The critical point, the first one is for the negative value, -3 and -36. The second one is +3 and +36. We have two critical point here. There are two critical point here. Here. Let's say I would like to determine whether this critical point is a minimum point or maximum point. Whether one of the or both of the point is a maximum or minimum. You need to decide. We need to decide by we can apply the first derivative or second derivative method. Okay, the first one is first derivative method. The first one is the first derivative method. Okay, how to apply the concept? Okay, the first one, let's say I draw this graph. You just draw one line. just draw one line. For example, let's say okay, there is a 2 point here. Okay, let's say I draw one line. Just draw one line. Let's see, there is one line here. Okay. So this line is for x. Okay, the first value of x is -3. The second value of x is positive 3. Okay, in order we know at these 2 points, the slope of the function is 0. We know that. But now we need to determine the slope of the function before -3, between -3 and 3, and after -3. So we need to find the slope. So just choose any number that less than -3. Let's say I choose the number is -4. You can choose any value as long as the value is less than negative less than -4. Less than -4. Sorry, less than -3. So the slope of the function is equal to f -4. F -4, this is equal to 18 minus 2 -4 to the power of 3. Okay, the answer is -40. Okay, so before -3, the slope of the function is negative. Okay, now we know that before -3, the function is decreasing. The function is decreasing. Now I choose one number between -3 and +3. Let's say that the number is 0. I choose this number. You can choose any other number like -1, +1, +2, and so on. Okay, so the slope of the function when x equals 0, this is equal to 18 minus 2 times 0 to the power of 3. The answer is 18. So the slope is positive. So between these two critical points, between -3 and +3, the slope is positive. You can find any other number to prove that the slope is positive, as long as the number is between -3 and +3. Now I find the next one is I need to identify the slope of the function after 3, after critical point of 3. So let's say I choose the value is 4. The value of is 4. So the slope of the function when x equals 4 is equal to 18 minus 2 to the power of 4, 2 times 4 to the power of 3. The answer is -40. The answer is -40. Again, after -3, after +3, after this critical point, the slope is negative. F prime x is negative. So based on this finding, we can conclude that this function is decreasing before -3, increasing after -3, and decreasing again after +3. So the function is decreasing before -3 and after +3, before critical point and after critical point. But the function is increasing in between -3 and +3. That's how to determine whether the function is increasing or decreasing. Okay, since we can conclude here the function is decreasing between negative infinity until negative 3, and also between 3 and positive infinity. And then the function is increasing between negative 3 and negative 3 and positive 3. Okay, the value of x, whether the value of that where the function is uh, increasing, increasing and decreasing. So okay, now we know we can decide which one is uh, what is the critical point. Now we know the answer. We get the critical point and the slope and the range where or the interval where the slope is increasing or decreasing. Okay, so the next one, the relative extrema. Uh, so far we have uh, two in other words, we have two critical point, negative 3 and positive 3. So now we need to determine whether which one is a maximum or minimum. Maximum or minimum. So based on the first derivative method, before negative 3, uh, we have 2 points here, negative 3 and negative 36. The second one is negative 3, positive 3 and positive 36. We have two critical points here. Let's say point A and point B. These two critical point. Okay, based on these two critical points, we need to decide which one is minimum or maximum point. Okay, first, based on the first derivative method, okay, we can determine this. We can determine whether this point A is positive, uh, uh, whether this point is a minimum or maximum. We we just check the slope, whether the slope is positive, the change of the slope. Before negative 3, the slope is negative. After negative 3, the slope is positive. The slope is changed from negative to positive. So in other words, since the change of the slope change from negative to positive, so the A is a minimum relative point. Okay. Then same, and whereas at point B, let's say at point B, when x equal 3, the sign of the slope is changed from positive to negative. The change of the slope is from positive to negative. So we can conclude that at point B, the critical point is at point B, that there is the point B is the maximum relative point. That's how to determine the minimum or maximum point. Okay, that's based on the uh, first derivative method. Okay, please remember we have second derivative method. Second derivative method. Second derivative method. Okay, so what is the second derivative method? We just uh, we just what we call it find the second derivative. Okay, again, our first derivative method, sin f prime x equal to 18 minus 2x squared. Okay, and then the second derivative method, and the second derivative is equal to 18 equal to 0 minus 4x equal to negative 4x. We have a negative, this negative 4x. So we have two critical points, negative 3 and negative 36. And then the second one is positive 3 and positive 36. That is uh, these two critical points. Okay, we are going to determine whether which point again this point A, point B. Okay, which point is a minimum or maximum? Okay, by using the second derivative method. Based on the second derivative method, we just replace the value of x negative 3 on the second derivative method. So the answer is negative 4 times negative 3. The answer is positive. And then for the second critical point, the value of x is positive. The value of x is positive. So the value of the second derivative is negative 4 times 3 is negative 12. So now we have two value of second derivative. The first derivative when x equal to negative 3, the second derivative is positive. So the graph is concave up. This one, concave up. But when x equal at x equal to 3, at the second derivative, second critical point, at critical point of 3, the second derivative is negative. So the graph is concave down. Concave up means there is the there is a minimum point. X equal to negative 3 is a minimum minimum relative point. Concave up at when x equal to negative positive 3, the graph based on the second derivative, the graph is concave down, show that at x equal to negative when at x equal to positive 3, x equal to positive 3 is a maximum maximum relative point. Maximum relative point. Okay, that's how to determine the increasing or decreasing range of function, and also to determine the critical point, whether the critical point is a maximum or minimum point. Okay, that's how to draw this graph. And also, if you refer to my additional file, I will show you the graph of this function. Okay, the graph of this function. Okay, let's just open the additional file, the cubic graph file. Okay, that is the function. Okay, again, there is the function of the graph. Okay, again, I just screenshot the graph. Okay. You can draw the graph by using apps, using any apps in the website. Okay, okay, this graph appears here. Oops, where is the graph? Okay, okay, there's graph of the function. Okay, again, we have critical point here. Okay, there is one critical point, 3 and 36. The second critical point here, -3 and -36. And then, as you can see, there's a point A and point B. There's point A and point B. At point A is a minimum relative. The point B is a maximum relative. And then before point A, the slope is increasing. Decreasing. Where the slope is negative. The first derivative is negative. Between A and B, the slope is increasing. The first derivative, the slope between A and B, the function has positive slope. The first derivative is positive. After point B, the function is decreasing, or the slope of the function is negative, or the first derivative is negative. And that's how we can find the whether the graph is increasing or decreasing, by using the first derivative and second, second derivative of the second derivative method. Okay, so as you can see here, by using this concept of derivative, we can determine the critical point. When we're talking about the critical point, we refer to the relative maximum or relative maximum point. And then at this critical point, the slope of the function is positive. The slope of the function is 0. The first derivative is 0. The second derivative is positive or negative at this relative point. Based on this based on the first derivative, we can also determine whether the graph is increasing or decreasing. Just how to determine this, how to determine whether the graph is increasing or decreasing. We just choose any value, any number of x, any value of x outside the critical point, before and after the critical point. That's how to apply this first derivative, or how to apply the derivative in the how to apply the derivative in this in the graph, and then what I'm trying to say is we can apply this concept, this derivative, the dy dx. We can apply this concept in order to find the slope of the function, whether the slope is positive or negative. In other words, any function, whether the function is linear or non-linear, quadratic or non-quadratic, cubic or non-cubic, log, exponent, and so on, we can find slope of the function by apply the derivative method. Okay, that's about the derivative. Okay, part C. Okay, I think that's all for today. I will stop at this page 11. For the next part, I will continue next week. I hope I can. I hope we are going to meet in Pusanika again. I hope we can meet at Pusanika in a face-to-face class next week. And then next week I will continue this page, the application of maximum and minimum in terms of total revenue, total cost, and so on. Okay. So our next meeting is next week. Next week is it's about I think 6 5 5 5 or 6 6 6 January of 26. I will continue this part, application of maximum and minimum. But after that, after this, and then after this part, after this page, this topic, I will continue to topic number 7. That's about the integration, the last topic of our class. Okay, I hope you can download the lecture material and for the lecture material from the UKM for you as usual. Okay, that's all for today. Okay, before I end this class, okay, just to remind you, for attendance, no need to scan any QR code. You just I will just record your attendance based on the attendance based on the attendance report that I can download from the UKM Folio. Okay, that's all for today. Any question before I end this meeting?
No, doctor.
Okay, if that's so, okay, see you next week in at Pusanika in our class as usual. Okay, that's all for today. Assalamualaikum and good morning. See you next week.
Thank you, Doctor.
Welcome. Welcome.
Doctor.